Let's look at Newton's second law, pulleys. Right. Advantage of the pulley system is that the force can be redirected in such a way that it always looks like the forces are acting on the same plane, either horizontally or vertically. So in this case, there's no need for resolving components. So you're not gonna find that maybe you have something like for example, like you are not gonna say, okay, here's your incline, your mass is sitting on the incline, and then there you've got a pulley. Okay, so attached there, and then you need to maybe kind of like resolve, maybe call this a perpendicular force, and then maybe call this a horizontal force. No, you do not need to do that. Okay, so pulleys redirect the force in such a way that it's like all the forces are on the same plane. So let's look at if you had, okay, a pulley system. Okay, where, okay, say body masses are hanging over there. So there's another two body masses are hanging. Okay. So put them like that. Okay. Now let's, okay, let's do this. Okay, so let's say that is body A and that's body B. Body A, let's say, is 10 kilograms. Body B, let's say, is 20 kilograms. Okay, so when you are working Newton's second law for pulleys, right? So you want to find, for example, most of the time, either number one, you want to find, or rather, they will mostly ask you for your acceleration, and they will also ask you for tension. So they will also ask you for to find the tension between the bodies. All right, so and then how do we work with that? Okay, so you need to kind of like work it in a bit of a very, very smart way. So I am going to, okay, so you need to draw your force diagram. So in that case, you're going to draw the force diagram for both bodies, A and B. So in order for you to work out the acceleration and the tension of the system, so what you need to do is make free body diagrams. Okay, so I'm going to have two free body diagrams for each body, for body A and for body B. Then you're going to put the forces for each. Okay, so there we go. Okay, now that we've put the diagram for each, so now we can label the diagrams. Okay, so you will have, so if you check for A over there, that's your tension. So that will be tension, right? For B, the tension is going to be up as well. So that will be your tension. Okay, and then you're going to have the force of gravity for mass A. So also there you're going to put your force of gravity for mass A. Then you're also going to have your force of gravity for mass B. So there I'm going to put force of gravity for mass B. All right. Now after doing that, now You cannot say that both tensions are pointing up, so they have a positive direction. No. With pulleys, you have to be very smart. When you put your direction, you need to choose a direction, right? You need to choose a direction for all your system, the whole of your system. So you cannot just say up is positive or down is negative. You need to choose it nicely. So you're going to draw a nice kind of like clockwise, okay? So which means anywhere where forces are involved, right? If they are pointing in the direction of those arrows, right? The vector will be regarded as positive. But if they're pointing opposite to those arrows, then the vector regarded as will be regarded as negative. Okay. Okay. So that is what is there. So now what to do here is you need to put equations for each. So put the equation for the body A, so which means you are having, for body A, you are having a positive tension, negative gravity. But for body B, you can see that the tension is pointing opposite to the arrows. So it's going to be a negative. And then the gravitational acceleration for B is going to be positive because it points in the direction of the arrows. So equation 1 for body A, we'll call it equation 1. So for F net, it will be positive tension, right, added with negative force of gravity for A, which will be equals to the mass A times the gravitational acceleration. Okay, so not times the gravitational acceleration, but it's going to be times the acceleration, okay, the acceleration of the system. Okay, so that's equation number 1. Okay, so equation number 2 would be for body B, or mass B, which will be your negative tension, and then plus your gravitational force for B, and that equals to mass times the acceleration of the system. Okay, then after you've done that, you are going to do a simultaneous equation. Okay, and then how do you do that? Okay, so you're going to add the two equations, put them together. Okay, maybe let me take it up here. Okay, so basically what you're going to do, you're going to say, okay, t equation 1 plus equation 2, so which is basically you have t minus FGA equals to ma times the acceleration. Then you have negative tension plus Fg of B, which is equals to mass of B times the acceleration. So adding the two formulas together, right, obviously you've got positive tension and negative tension. So when you put those two together over there, when you add them, they're going to cancel out. So you're going to get 0 for that. Then you are going to be left on the after when adding the two equations, you're going to be left with F positive Fg of B, and then with the negative force of gravity of A, which is equals to the mass, okay, of A, that plus all right. And then obviously to find the acceleration, you can factorize the acceleration out, which will be that. And then on the other side, you're going to have mb times g minus ma times g. All right, so which you are going to, if you factorize that one out as well, you're going to have g minus b minus a. All right, if you divide both sides there, so you're going to end up with divide by mass a plus mass b, and this is equals to your acceleration. All right, so you can see basically it's just a ratio of the difference of masses divided by the sum of the masses times the gravitational acceleration. Then this is obviously gonna give you, so you're gonna have 9.8. The difference of the masses, mass B is 20 minus mass A is 10, all divided by 20 plus 10, okay, so obviously it's the same as multiplying 9.8 by 1 over 3, of which if you get the answer for that, you will get okay, you should get something about 3.27 meters per second squared for your acceleration. Okay, so that's the value of your acceleration. After you have found your acceleration, then you can use that to find your tension. So you can use one of the equation, either equation 1 or equation 2. So equation 1 looks almost finished, so you can say that tension equals to mass of A times the acceleration, right, plus, right, FGA, when it goes to the other side, it will just be ma times force of gravity. Okay, so basically it's a matter of just putting in the values. Mass A is 10. The acceleration is positive 3. Write it properly. So that will be 3.27 plus 10 into 9.8. And then you should get something like, okay, 130. Okay, so it means that your tension over there is basically 130.67 newtons. All right, So for body A, all right, the tension is up, all right, or you can say the tension for A is actually clockwise. And that's how you work with pulleys. Make sure when you put direction, put it as a clockwise and not just as up or down is positive, right? So if you can do this, you can work out any problem with tension and has pulleys. So what if you're working with the pulley system and one object is sitting on a surface whereas the other one is hanging? Right, it's a bit of a similar thing. Right, the first thing you do is you are going to choose your direction. So with pulleys, you always make sure that you choose your direction in a very smart way, like I said. So you need to make sure you choose your direction in a clockwise or anti-clockwise. So which means in this case, right is positive and down is also positive. Okay, which means any force that is pointing opposite to that, right, is going to be negative. Right, so what forces are going to be existing? So for the body A, right, you already have the friction represented there, but you're going to have also the tension there. Right, so you're going to have the tension, and then on the body B, mass B, you're going to have the tension, okay, pointing upward there, and then you're going to have the force of gravity for mass B. So how do you work this one out? So remember, you can do your simultaneous again. So for body A, so it's going to look like this. And then you are going to, okay, put the forces on there. So on the one side, you've got tension. On the one side, you've got force of friction. Right, that's for body A, mass A. Okay, so now that you've got that done, so I'm only going to show the forces acting on the surface, okay, parallel to the surface. I'm not going to show the normal force or the force of gravity in this case because they are completely irrelevant. Okay, so now that's what you have. So you are going to, if you, according to the direction that you chose, you're going to have a positive tension and a negative force of friction. Right, now let's go to mass B. Okay, so with mass B, okay, let me put mass B here. With mass B, put your forces as well. Okay, so only that with mass B, the upward force is the tension, the downward force is the force of gravity of B. So those are, I'm going to consider the vertical forces because B is hanging. And in this case, according to the direction that you choose, you can see that downward is positive. So you're going to have a positive Fg and a negative tension. So now we're going to do the equations. So for body A, I will call that equation number 1. So for equation number 1, we know that we know that F net for A is equals to mass of A times the acceleration, which is therefore equal to, in this case, positive tension minus the force of friction, put it with its negative like that, equals to mass of A times the acceleration, and that's equation number 1. Then you go to your mass B, so your F net, so you're going to say, okay, F net for B equals to mass of B times the acceleration. The acceleration should be the same for both, and this is going to be, okay, and this is going to be your obviously positive force of gravity for B minus, okay, put the negative tension with the sign there, okay, mass of B times the acceleration. Right, so this will be your equation number 2. Now what you're going to do now is to put equation number 2 and equation number 1 together. Okay, so I'm gonna rewrite, let me rewrite equation number 2. Let me rewrite it again so that it can be similar to how equation number 1 is written. So I'm going to write negative tension plus Fg of B. Okay, so now when you do our simultaneous, we're going to say we're going to add equation number 1, add it on equation number 2, which means we are taking T minus force of friction equals to mass of A times the acceleration, and we put again negative tension plus force of gravity of B, right, equals to mass of B times the acceleration. Okay, so in this case you can see that your tension, you got positive and negative tension, you add those two equations together, what you will end up with is no tension. The tensions will cancel and you will end up with positive force of gravity of B minus the force of friction, and this is equal to mass of A times the acceleration plus mass of B times the acceleration as well. So you can factorize out the acceleration. Okay, obviously FGB is basically just mass of B times the gravitational acceleration minus the force of friction all over, okay, if you factorize the acceleration out, so there you will end up with A into mass A plus mass B. Okay, so if you divide both sides, so you end up that's equals to A, you're going to end up with mass A plus mass B. And yeah, I can remove that. I just wanted to show what will happen. So then that will be your acceleration. Right, then the last thing is to just substitute the values. So it's going to be mass of B, which is 9 times 9.8 minus 20 all over, all right, 20 plus 9 is going to be 29. That's going to be your acceleration. And then all that's left is just to put that in a calculator and say 9 times 9.8 minus 20 and then divide by 29. Okay, you should get at least somewhere about 3.35, okay, meters per second squared. That's your acceleration. All right, and since the acceleration is positive, it means that the whole system is accelerating in the direction that we chose to be positive. So it's indeed accelerating right, that way. Since the hanging object is continuing to go down, and the object on the surface will therefore be moving to the right. Now, to find the tension, you are going to use either equation 1 or equation 2. I will prefer to use equation 1 in this case. So because it's pretty much solved, so it will mean that tension equals to, you just put the friction over to the other side, equals to mass A times acceleration plus force of friction. This is going to give you, just substitute mass of A is 20, acceleration 3.35, and then plus force of friction, which is 20. So you times that with okay, and this should give you something about 67.03, and that's Newton. And obviously for A, tension is to the right. And that's how you deal with when one object is on the surface and one object is hanging.